Namaste. In the previous chapter, we looked at hydrocarbons specifically with respect to alkanes, alkenes, alkynes. We saw what they were, we looked at how to name them, we looked at how to prepare them, we looked at what are the various chemical properties that they give, and finally we looked at their uses. In today's class, we'll continue further and look at the next set of hydrocarbons called as aromatic hydrocarbons. Now, as the name aromatic indicates, it has something to do with aroma. So when these compounds were known for the first time, they had a characteristic smell associated with it. Hence, these compounds were called as aromatic compounds. And then we understood in the initial class where we looked at the definition, aromatic compounds are primarily compounds which have a benzene ring. And we also say derivatives of benzene are aromatic compounds. Today's class, we'll primarily look at the methods of preparation, the various methods of preparation of aromatic compounds, and specifically look at the properties. So what are the various methods of preparation of benzene? The first method is starting from acetylene by a process called as cyclic polymerization. Now, we already came across this term called as polymerization. We also saw cyclic polymerization in the previous chapter or the previous part of hydrocarbons. We'll continue this further here, starting from acetylene. So when acetylene or ethine reacts with red hot iron, so it is passed through, acetylene gas is passed through red hot tube of iron at 873 Kelvin, what happens is there is rearrangement of bonds. Now, bonds get rearranged like this to give us the final compound, which is benzene. Yeah, C6H6. Okay, so where we clearly see, we take 3 moles of acetylene. Acetylene is an alkyne, but there is rearrangement of bonds to give us a benzene. So they combine to form one unit. Hence, this comes under the type of reaction called as polymerization. So 3 units of acetylene combine to form 1 mole of benzene. So for this, we need red hot iron, 873 Kelvin. Clear? So this is trimerization or cyclic polymerization. Trimerization. So tri is 3, mer means unit. So 3 units will combine to form 1 single unit. This is what is called as trimerization. The second method is starting from a compound called sodium benzoate. Sodium benzoate by a reaction called as decarboxylation. Now, you got introduced to various terminologies in terms of chemical reactions in the previous chapter: hydrogenation, halogenation, hydrohalogenation, dehydrohalogenation, dehydration, etc. Right? So you are familiar that whenever the term DE or the prefix DE is used, it indicates removal. So what is being removed here? Decarboxylation, which means there is removal of carbon dioxide. So what are we removing? We are removing carbon dioxide. From where are we removing carbon dioxide? From sodium benzoate. So let's have a look at what sodium benzoate is. This is sodium benzoate, which is sodium salt of benzoic acid. So sodium benzoate, upon reaction with sodium hydroxide in the presence of calcium oxide. So this mixture, a mixture of sodium hydroxide and calcium oxide, is called as soda lime. Very important. I want you to remember this. So you'll come across this in your second year as well. Soda lime is a very good decarboxylating agent. It removes carbon dioxide from any given molecule. Now, what is the composition of soda lime? It's a mixture of sodium hydroxide and calcium oxide. So when these two combine, Na2CO3 is removed. So NaO from NaOH, Then COONA from sodium benzoate is removed as sodium carbonate, giving us finally benzene. Okay, so removal of carbon and oxygen, decarboxylation in the form of sodium carbonate. So this is what is called as decarboxylation reaction, a very important reaction. The third method is starting from phenol by reduction. Now we have already come across the different definitions for reduction. Reduction can be understood in three different ways: addition of hydrogen, removal of oxygen, or gain of electrons. So these are the three different ways in which we can understand reduction. Let's try to see what happens in the case of phenol. So this is phenol, benzene with an OH substituent. To this, I add zinc in the presence of heat. So what does zinc do? Zinc will take away the oxygen that is there in phenol to go out as zinc oxide. If it goes out as zinc oxide, in place of oxygen, who gets replaced? Hydrogen gets replaced. Here, zinc is behaving as a reducing agent. Why is it behaving as a reducing agent? Because it takes away the oxygen to get converted to zinc oxide. And overall, when I look at the reaction, phenol gets converted to benzene upon removal of oxygen. Removal of oxygen is called reduction. Yeah. Let's solve a few MCQs here. Phenol plus zinc in the presence of heat gives us A. What is A? Pretty straightforward, right? A benzene, B acetylene, C ether, D none of the above. It's benzene. Sodium benzoate in the presence of X gives us benzene and sodium carbonate. What is X? Is it AlCl3? Is it NaOH plus CaO? Is it ferric chloride, or is it sodium metal? We just came across this. Soda lime. What is soda lime? Soda lime is a mixture of sodium hydroxide and calcium oxide. Option B is your answer. Let's continue further with the chemical properties of benzene. Now, benzene, this is the structure of benzene. It has multiple bonds. And the moment we say multiple bonds, we talk about unsaturation. And we saw what kind of compounds unsaturated compounds undergo. We saw it specifically with alkenes and alkynes. What is one characteristic property of all unsaturated compounds? Yes, it is addition reaction. They add on to something to form a saturated compound. So benzene can also undergo a reaction where it gets converted to saturated, but there is a small problem. Now, what is the problem? Now, you see, when we spoke about the various effects that is seen in organic systems in the previous chapter, we came across a resonance effect. What did we say is important for resonance? We spoke about something called as conjugation. Remember, what are the different kinds of conjugations? Yes, pi-pi, pi charge, and pi lone pair. So these are the three types of conjugation that is seen in organic systems. The conjugation means two things present at alternate position. So when you look at the structure of benzene, here you have pi bonds present at alternate positions. In fact, all the three are alternate to each other. Therefore, what happens? Yeah, so this clearly talks about the nature of the carbon atoms, which is sp2 hybridized, and all the pi bonds will undergo delocalization, because that's what we said. Conjugation leads to something called as delocalization. Delocalization is nothing but movement of pi electrons. Now, how do they move? They move like this to give us the next structure, which looks like this. This is the second resonating structure or a canonical structure. Now, when you look at this compound, even here there is conjugation. Even here, all the three pi bonds are present at alternate positions, which will lead to delocalization once again to give back the previous structure that we got. So this process keeps on happening, where 1 gets converted to 2, 2 gets converted to 1, 1 gets converted to 2, 2 gets converted to 1. Hence, we refer to this process as resonance. And due to delocalization of pi electrons, structure 1 and structure 2 does not exist. Now, what do I mean by it does not exist? They keep shifting from one form to the other. Hence, we represent it how we represent it in the form of a resonance hybrid, which is structure 3, where we write a circle inside. And we also spoke about what the circle is all about. What is the significance? The significance is that the pi electrons are not fixed. Their positions are not fixed. Instead, they keep moving around inside all the carbon atoms. Got that? So this is how we write the structure of benzene. So the ring shows delocalized pi electrons. Okay. So due to delocalization of pi electrons, benzene serves as a source of electrons, and thus it undergoes electrophilic substitution reactions. So we will study this better when we look at electrophilic substitution sometime in this class. But right now you need to understand, when you compare addition to substitution, they prefer to undergo electrophilic substitution than addition, even though benzene is unsaturated. This is primarily because the pi bonds are not fixed in their positions. They keep moving, they keep shifting from one place to the other. Yeah. So what are the various reactions of benzene? So first one is addition. So we said addition can also happen. So what are the different kinds of addition? The first one is hydrogenation, or addition of hydrogen. So here, when benzene is heated with hydrogen in the presence of nickel catalyst, finely divided nickel. So it's the same catalyst that we used previously. At 453 to 473 Kelvin, it gives us cyclohexane. Under special conditions, when the benzene undergoes addition reactions. So this is what we said. We said previously that when you compare electrophilic substitution to addition, electrophilic substitution is something that is common, whereas addition do not happen normally. For that to happen, it can only happen under extreme conditions or special conditions. Yeah, so let's have a look at the reaction. Benzene reacts with 3 moles of hydrogen in the presence of nickel at 453 or 458 to 473 Kelvin. The bonds break and hydrogens get added to give us cyclohexane. This is your final product. We can also add chlorine. So chlorine can also get added to benzene, where it can react with 3 moles of chlorine in the presence of bright sunlight or UV light to give benzene hexachloride. So benzene can add on to 3 moles of chlorine in the presence of sunlight or UV light to give us benzene hexachloride. So chlorine atoms will get added. Benzene hexachloride is also called as BHC in short, which is benzene hexachloride. It is also called by certain common names, gamexane or lindane. So at this point, I want you to take a homework. Find out what is the use of gamexane or lindane, which is the other names for benzene hexachloride. So this is the second addition to benzene, which is chlorination. Uh-oh, I accidentally gave you the answer, but go ahead and do that homework. Find out, okay, since the answer got flashed there for a slight moment, some of you would have seen it. or if you're seeing the recording here, you will go back and look at what that is. So find out what is the current status. Is it still used as that, or is it not being used? Is there any prohibition in its use? Just go ahead and find that out. The third one is addition of ozone. So similar to what we did before in a reaction called as ozonalysis. Even here, benzene reacts with 3 moles of ozone. Why 3 moles? Because I have 3 double bonds. So 3 moles of ozone to give benzene triozonide, which is the first step. Benzene triozonide further reacts with water in the presence of zinc to give us glyoxal. Okay, so this is what happens. Let's understand it in the form of a chemical reaction. So benzene reacts with 3 moles of oxygen. The ozone gets added across the double bond to form the ozonide. Yeah, like this, benzene triozonide. Now you would be familiar with writing the structure of an ozonide because you have come across that in alkenes. This ozonide, in the presence of zinc and water, there is cleavage to give us CHO, CHO, and hydrogen peroxide. This is called as glyoxal. Now, what is zinc doing here? So zinc basically acts as a reducing agent to avoid further oxidation of glyoxal. So it acts as a reducing agent so that glyoxal will not undergo oxidation in the presence of ozone. Let's solve a few MCQs at this point of time. Phenol on reaction with zinc gives alcohol, benzoic acid, benzene, or all of the above. We've already come across that. Zinc, when it reacts with phenol, it takes away oxygen to give us what? Yes, give us benzene. Benzene reacts with chlorine in the presence of bright sunlight to give chlorobenzene, benzyl chloride, BHC or gamexane, or parachlorobenzene. So this is also pretty straightforward, BHC or gamexane. Acetylene gives benzene on cyclic polymerization, reduction, oxidation, or none of these. So which of the reactions to acetylene do we get benzene? Yes, it is cyclic polymerization. Benzene plus ozone gives A. The product A is benzene triozonide, ketone, carboxylic acid, or is it benzene? It is straightforward again, benzene triozonide. Let's move to the next set of chemical properties. We looked at addition reactions. Now we will look at substitution reactions. And remember, we came across the kind of substitution already in today's class in one of the previous slides. What was that substitution? Yes, it was electrophilic substitution. Remember when we did the basic chapter where we did homolysis, when we introduced homolysis to you, we said a bond can break in different ways. Which are the different ways? Yes, homolysis and heterolysis. Homolysis is lysis, where the bond breaks exactly at the center to give us what? Give us free radicals. Heterolysis is unequal breakage, or the bond breaks away from the center of the bond and towards one of the atoms. Such breaks will give us ions or species called as electrophiles or nucleophiles. So when I introduced that, I told you what is an electrophile and what is a nucleophile. Can you try to recollect that? Who is an electrophile? Yeah, some of you are able to recollect. Electrophile, the word electrophile can be broken into 2 parts, electro and phile. Electro means something to do with electrons. Electrons are negatively charged. Phile means to like. So electrophiles are species which like negatively charged centers, or which like centers where there are electrons. So naturally, what should they be? They should be positively charged or deficient in electrons. Clear? So this is something that we have already studied in the first chapter. So reactions in which one or more hydrogens of benzene are replaced by groups like Cl, Br, NO2, SO3H is called as substitution reaction. So here when we talk about substitution of benzene, we are looking at substitution of a hydrogen of one or more hydrogens of benzene by groups like chlorine, bromine, NO2 or SO3H. Clear? So let's look at the first one, nitration. When benzene is heated with nitrating mixture. Now what is nitrating mixture? It's a mixture, equimolar mixture of concentrated sulfuric acid and concentrated nitric acid. Now what is an equimolar mixture? Equi is equal, molar is same number of moles. So if I take 2 moles of nitric acid, I'll have to mix it with 2 moles of sulfuric acid. If I take 8 moles of nitric acid, I'll have to mix it with 8 moles of sulfuric acid. So this equimolar mixture of concentrated nitric acid and sulfuric acid is called as nitrating mixture. So when benzene is heated with nitrating mixture at 313 Kelvin to 333 Kelvin, it gives us nitrobenzene. So what is nitration? Substitution of hydrogen atom of benzene by a nitro group. Now, who's a nitro group? An NO2 group is called as nitration of benzene. So let's have a look at the reaction. Before that, let's see what actually happens in a nitrating mixture. So I take nitric acid, mix it with sulfuric acid. There is removal of H3O plus and liberation of NO2 plus. Now this NO2 plus is nothing but your electrophile. We said electrophiles are somebody who likes electrons. They generally are positively charged. So NO2 plus is positively charged and it likes electrons. Hence we call it as an electrophile. This is the electrophile that is used in nitration. So very important for you to know who is the electrophile in each one of these substitution reactions. In fact, this is one very, very favorite question of all competitive examiners. They give you 4 options and ask you which is the electrophile involved in nitration, which is the electrophile involved in substitution or in sulfonation and so on. Clear? So it's important for you in each of these reactions to know who is the electrophile. So in the case of nitration, the electrophile is NO2 plus. So let's have a look at the chemical reaction. So benzene reacts with nitric acid in the presence of concentrated sulfuric acid. There is removal of water. So H plus will take away OH minus to go out as water. In place of hydrogen, we have NO2 plus getting substituted. So NO2 gets substituted in place of hydrogen and benzene, giving us nitrobenzene. And you can clearly see here through the arrow mark, when H plus is abstracted, there is a negative charge on that carbon atom. That negative charge is nothing but excess electrons that have been left by hydrogen while it went out. That is being attacked by whom? By the electrophile, or electrophile gets attracted to that negative charge to form a bond. And once it forms a bond, we get the product nitrobenzene. Clear? Very, very, very important reaction. Let's look at the second one, halogenation. So nitration is nothing but substitution of hydrogen with NO2 group. So what is halogenation? Pretty straightforward. Substitution of hydrogen with a halogen atom. Either chlorine or bromine is called as halogenation. So what is used for halogenation? For halogenation, we used anhydrous aluminum chloride or anhydrous ferric chloride. Here we use either ferric chloride, ferric halides, or we use anhydrous aluminum chloride for the reaction to happen in the presence of chlorine if it is chlorination, or bromine if it is bromination. So when I take this, Chlorine in the presence of aluminum chloride gives us Cl plus as the electrophile. So this is the reaction where there is generation of an electrophile. So electrophile which is Cl plus is generated. This Cl plus then attacks my benzene. Here H plus takes away Cl minus to go out as HCl, and Cl plus will attack those two electrons in the form of the negative charge to form a bond with carbon atom, giving us chlorobenzene. When benzene is treated with excess of chlorine in the presence of anhydrous aluminum chloride, it gives hexachlorobenzene. Now, if it is carried out with excess of chlorine, in the previous case, we only took 1 mole of chlorine, whereas if I take 6 moles of chlorine, what will happen? All the 6 hydrogens of benzene will be substituted with chlorine atom to give us hexachlorobenzene. So this is substitution with excess of chlorine. In this reaction, all the 6 hydrogen atoms, as you can see, are replaced by chlorine atoms. Similarly, bromine, if it is substituted, we call it as bromination. When benzene reacts with bromine in the presence of ferric bromide, it gives bromobenzene. So benzene, when it reacts with bromine in the presence of ferric bromide will give us the electrophile. Who is the electrophile? Br plus is the electrophile. So Br plus is first generated, and that Br plus will then attack benzene to form bromobenzene. Yeah, so one of the bromine atoms, Br minus, takes away H plus to go out as HBr, and Br plus will attack the pair of electrons to form a bond with chlorine, with carbon, to form bromobenzene. Pretty straightforward. Third one is sulfonation. Now, chlorination is substitution of hydrogen with chlorine atom. Nitration is substitution of hydrogen by a nitro group. What is sulfonation? Substitution of hydrogen atom benzene molecule by SO3H or a sulfonic acid group is called as sulfonation. So here hydrogen is replaced by SO3H group. So let's have a look at the reaction. When benzene is heated with fuming sulfuric acid, which is also called as oleum. So fuming sulfuric acid, oleum, which is nothing but a combination of sulfuric acid and SO3 at 373 Kelvin, it gives benzene sulfonic acid. Yeah. So let's have a look at the reaction to understand better. Benzene reacts with sulfuric acid, fuming sulfuric acid to be precise. OH takes away H plus, or OH minus takes away H plus to go out as water. In place of H plus, SO3H minus gets substituted, SO3H plus gets substituted to give us what? To give us benzene sulfonic acid. So what's happened from left to right? Hydrogen of benzene is replaced by SO3H group. So hence this reaction is called as sulfonation, and the final product is benzene sulfonic acid. Let's solve a few MCQs here. Benzene plus HNO3 concentrated, H2SO4 concentrated gives us X plus water. What is it? Option A, nitrobenzene. Option C, benzene. Option C, benzene sulfonic acid. Or option D, nitrosobenzene. So you will know this by now. Nitrobenzene. In sulfonation of benzene, the attacking electrophile is SO3, SO3H, H plus, or OH minus. Now, in sulfonation, now this is a very important question. Please take this as quite important, because this has been asked multiple times. Because Sulfonation is the only example where we have a neutral electrophile among what we have studied. We studied chlorination, we studied bromination, we studied nitration. In all the three cases, the new electrophile was positively charged. It was either Cl plus or Br plus or NO2 plus. Whereas it is in the case of sulfonation, the actual electrophile, the attacking electrophile is SO3, which is a neutral electrophile. So very, very, very important. So at this juncture, I want you to take a homework. When somebody is positively charged, we know that they are naturally attracted towards negative. They are naturally attracted towards electrons. Hence, they are called as electrophiles. So if SO3 should be considered as an electrophile, it should have a positive charge there, but it does not. It is a neutral electrophile. Now, how can somebody be neutral and still behave as an electrophile? How can somebody be neutral and still get attracted to electrons? This is the question that I want you to answer. So find out why SO3 is an electrophile in spite of being neutral. Okay, yeah. Let's look at the next set of reactions. Friedel-Crafts alkylation, which is again substitution. Substitution of a hydrogen atom of benzene by an alkyl group is what is called as alkylation. So substitution of hydrogen with an alkyl group is called as alkylation. So pretty straightforward, as the name itself indicates. So when benzene is treated with an alkyl halide in the presence of anhydrous aluminum chloride, it gives us alkyl benzene. So this is the statement of the reaction. Let's have a look at the reaction for a better understanding. Benzene reacts with alkyl halide. In this case, we're taking methyl chloride. So what do you think might happen? In the presence of anhydrous aluminum chloride, in general, whenever an alkyl halide reacts with aluminum chloride, the electrophile R plus is generated, which is what is used in this reaction. So in this case, CH3 plus is the electrophile. So what will happen to hydrogen? H plus will be taken away by Cl minus to go out as HCl. Now in place of H plus, who attacks the electrophile, which is CH3 plus, will attack. It will attack the negative charge. It will form a bond using those two electrons to form toluene or alkyl benzene in general. Clear? So toluene is what is obtained. There's one more reaction under Friedel-Crafts, which is called as acylation reaction. If an alkyl group gets substituted in place of hydrogen and benzene, we call that reaction as an alkylation. If an acyl group gets substituted in place of hydrogen and benzene, we call such a reaction as an acylation reaction. So for an alkylation, I need an alkyl halide. So therefore, for an acylation, I would need acyl halide. So that is what is indicated in the statement here. When benzene is heated with an acyl halide or acid anhydride in the presence of anhydrous aluminum chloride, it gives acyl benzene. So let's understand what is acyl halide. So this is acyl halide. RCOX is nothing but acyl halide. RX is nothing but alkyl halide. RCOX is called as acyl halide. So when acyl halide is made to react with aluminum chloride, what happens is there is the generation of the electrophile. And who's the electrophile? RCO plus. So RCO plus is our electrophile, which is called as the acylium ion or acylium ion. Clear? Acylium ion is what is formed. This acylium ion will attack the benzene atom, the benzene group, sorry. So in benzene, hydrogen of benzene is taken away by Cl minus to go out as HCl. in place of that hydrogen, who actually behaves as the attacking reagent, RCO plus. Here it is CH3CO plus. So CH3CO plus will attack the negative charge that is there on benzene, form a bond, gives acetophenone. So it gives acetophenone. Clear? Pretty straightforward. In the previous case, it was substitution of hydrogen by an alkyl group. In this case, it's substitution of hydrogen by an acyl group. Clear? We can also use acetic anhydride. In the previous example, we took an acyl halide. We can also take acetic anhydride. So this is acetic anhydride. You can also take anhydrides. If I take an anhydride, the product that is removed will be an acid. And in place of hydrogen, just like the previous case, we have the acyl group. So we still get acetophenone, but the other product instead of HCl will be an acid. That's the only difference. Let's look at a few MCQs. Acylation of benzene gives toluene, benzene hexachloride, alkyl benzene, or acetophenone. So acylation of benzene will give us acetophenone. Alkylation of benzene is nucleophilic substitution, electrophilic substitution, free radical substitution, or addition reaction. It is an electrophilic substitution reaction. So with this, we come to the end of this chapter where we studied the various properties, the various methods of preparation of aromatic hydrocarbons. In fact, this, whatever I have done in today's class, is extremely important because you will come across these reactions in your second year as well. So in your second year, you will come across chlorination, sulfonation, nitration, Friedel-Crafts, alkylation, and acylation with respect to the next set of compounds that we will study. So these reactions form the foundation now. Ensure that you understand each of these reactions. So that's the reason the homework for today is I want you to write each one of these reactions two times. Substitution, electrophilic substitution reactions. Which are the 4 electrophilic substitution? Halogenation, nitration, sulfonation, and Friedel-Crafts reaction. So these 4, I want you to write two times. Also indicate who is the electrophile, which is the attacking reagent in each one of these cases, because understanding that is necessary to find out what gets substituted. Okay. All right then. So it was a good set of understanding today. Make sure that you apply it for your better understanding. So until the next class, namaste. Thank you.